Yes, but it's different. It's different.
Back to the Future is probably the best trilogy.
Back to the Future was 1985 to 87. Anyway, the Professor Brown, Dr. Brown, created a time machine that was a DeLorean, and it had to get to 88 miles per hour to break the speed of sound or time or whatever, to break the time time and space continuum. Thank you.
To use a flux capacitor.
Yes.
That's a smart word, Ray Ray.
It's also a made up word. So.
Yeah.
Well, actually, a flux capacitor, I think, is a real thing. Capacitors you'll find in anything electric, but flux is like change,
Oh,
and
I thought it was.
yeah, and that's also the soldering stuff that you use too. So
That's a thing.
yes, flux is a real thing,
Oh.
but I think they put flux on it fictitiously. There are lots of capacitors all over the place, up on the power poles, all that mess. But anyway, okay, no, not the. Okay, so x equals the directed distance from the y-axis, okay? And y equals, or f of x equals, is the distance from the x-axis, whether it's positive or negative, okay? Something is a function if it passes the vertical line test, and that vertical line only intersects the graph at one point. Okay, so that's what that was. It's increasing if for any two x variables where the first one is less than the second one, then the first y value is less than the second one. Okay, when we talked about increasing and decreasing, so if you're looking at a line, if you had something like this, okay, this part is increasing. Okay, you always read from left to right, but this part is decreasing, and it changes direction at the vertex. Okay, now it's constant if it's flat, like that, or if there's a constant section of the graph, I don't know, something like that. This is the constant part right there. Now, that part. Okay, so a function is even if for each x in the domain that the negative x is equal to the positive x, okay? And it'll have symmetry about the y-axis, okay? A function is odd, and it can be slid around the graph if for each x in the domain that the f of negative x is equal to the negative f of x. So the y value changes sign when the sign on the x value changes. Okay, then we did this, finding the domain and range. Okay, we started at -2, but it could not equal because of the open circle, and it ends at 4 right there, and it can equal the 4 because of the closed circle. Okay, and if you didn't do the interval notation, you could do, does anybody remember what this is called? What notation this is called?
Interval.
Maybe that is the interval.
Set.
It's not set notation when you like list all around.
I forget.
I think it is interval because that's when you do like I think that,
Let's see here.
If you kept my notebook from last year.
Types of notation.
Miss Cooper, I have a question.
Yes, sir.
If you had like a regular graph that just went like y with the next one, like one of those, where it's just like a line, would that be a constant? Kind of like it goes at like the same thing forever, or is it still like a?
It has a, it might, if it's a line, it has a slope. And if, as long as the slope doesn't change, or it doesn't end and then change, like in a piecewise function, then it's a constant rate of change, but it's not constant. Okay. So, intervals and interval notation, evaluating function, function notation. Let's see here.
70s. You know how the girls used to put like colors on and like blue eyeshadow? I feel like that's what that gives me that vibe. But don't just think my word for it, because I don't even got to use that.
2,3, that's putting it in there.
At home, I think of myself as a dad, and I'm like,
I'll find what that notation is really called. I don't recall what it's called. Anyway, so because it didn't equal, that's why it was the soft bracket. Because the 4 did equal, that's why it was the hard bracket. Okay, then we said when x is 0, what's y? Well, here's 0, so y is 3. When x is 2, y is -5. And when f is 4, y is -3. Okay? And we talked about how the range went from -5, and it equaled it because it went through -5, all the way up to +3, but it did not equal the +3. You with me, Haley, or are you zoned out?
a little bit better.
Okay. Okay. What are you doing, sweetheart?
Give me all these today that we're gathered about that.
All these papers, I'm listening. I'm good at multitasking. But all these
Okay,
papers,
because I'm
I'm
not.
listening on iPad, and I'm finding out math work, which is how this all began.
Okay. All right. So vertical line test. They wanted to know if each of these was a function.
Miss, can you make all
This
these
is part of the reason why some of y'all had trouble on that test, because I'm not getting your full attention, Austin.
Did you grade those?
Maybe.
Just wondering.
I don't remember.
Okay.
Or maybe that's what I took home to do and I didn't do. I'll have it for you tomorrow for sure.
No, I don't want to. I definitely
Okay.
thought I understood a lot.
Now, so first thing you had to do was solve it for y, then you put it in the calculator, and we talked about it could be in this form or this form. And it came out like this. So yes, that passes the vertical line test. Okay. Will you please quit doing that?
He doesn't know how to stop.
This one you had to solve for y. Okay. I know you are. At least you're attending, but it's distracting me horribly. Uh-huh. Uh-huh. Okay. So we got down to y squared equals x minus 1. We had to take the square root. Okay. And our calculator only showed us the positive, because the negative part of it down here is imaginary numbers and so forth. But that we could put the negative part on there. Okay. And this one does not pass the vertical line test because it would hit twice everywhere except for the vertex right there. All right. Then the last one, we had to do a bunch of hee-haw, and we got it solved for y. And once we graphed it, yes, it is a function, but I guess we should have said that x cannot equal 0 because it doesn't exist at 0. We should probably add that one little piece. Okay, now, so increasing and decreasing. Okay, the big thing is to remember to read it from left to right. Okay, we hit the line right here, and it's easier to bounce down. So this is decreasing. Okay, it's decreasing from -1 to 1. Okay, because that's where it lines up right here on the x-axis. All right, then it's constant. So we're decreasing. And then we're constant from 1 all the way to 5. And then we increase from 5 to 7. Okay, so is everybody okay with the idea of increasing and decreasing looking at a graph? Okay, they may not give you the graph, but that's why we have our handy dandy calculator, so you can put it in and you can see it. Okay, now, so then it says use the graphing calculator to determine the open intervals. So yes, this is interval notation, and I think they had a mistake on this when they did it. Let's look at this one real quick. Y equals clear. X cubed minus 3x squared plus 2 graph. Oh, well. Okay. So we're increasing from negative infinity to, let's just double check. Okay. To 0. Okay, because we went from -2 to 2. So negative infinity to 0. Okay, and then there should be a hard bracket there. We talked about that the other day. I think whoever made the key just messed up and didn't do them. Okay, then it's also increasing from this point, which looks like it's probably 2. So second table. Okay, so yeah, at 2, it goes from -2 to +2. So from 2 to positive infinity. So that should be a hard bracket and a soft one on the infinity. And you put the union symbol because there's more than one interval of increase. Okay, you'll just stick that union symbol in between. All right, and then it decreases between 0 and 2 because that's where it's sliding down right here. Okay, and really and truly, those should be hard brackets. Okay, there's no constant there. All right, this one, math. Absolute value of x plus 2, get out of it, plus absolute value of x minus 1, get out of it, and then minus 2 graph. Okay, on this one, let me readjust my window, zoom 6. Okay, on this one, we decrease from negative infinity to 2, -2. Okay, that should be a hard bracket there. We're constant from -2 to 1. And then from 1 to infinity, we increase. Okay, is everybody good with that? Okay, you sure? Because you weren't Friday.
Yeah, I kind of got it.
Okay. All right, now, so relative minimum and maximum values. And you might see it as minima, or maxima. You often see those words. Okay? And it says relative. So it depends where you are on the graph. Okay? Because you're a relatively happy person, or y'all are relatively happy in my room. Okay? Relatively. You don't dislike me. You'll put up with it. You know, you just don't like the course. Okay, that's cool. All right. Whereas you are relatively unhappy around Ms. Berry.
She's not even here
Yeah.
anymore.
I know, but most people did not like her. Okay? And I don't mean that to be rude, but most kids really griped about it. Okay? So relative has to do with where you are, is my point here. Okay? So relative maxima or maximums are maximums at the top of the hill or down in the valley? They're at the top of the hill. Okay? These are relative maxima. I guess maxima is plural. Okay? And then relative minima are these right here. Okay? So it depends on where you are on the number line as to what your maximum and minimum is. Okay? Now, so based on the definition above, label the points. Oh, we already did that. Okay. So let's flip over. All right, we're going to explore techniques for finding extrema. Maybe that's what I was trying to remember. Extrema. The extremes. Okay. The relative maximum and minimum values for quadratic functions later. So we're going to use the graphing calculator to help us with this. Okay, so I'm assuming this is it, but let's just double check that. Clear. X cubed minus 4x, x cubed minus 4x plus 1. Graph. Looky there, that is it. Okay, so slide it up here a little bit. All right, now, so a local maximum value. A local maximum value. Well, what's the only maximum shown here?
Whatever right above the 4. It looks like it's a little bit above 4.
Okay, I think it's going to be just 4. So that's going to be -1. Okay, and it occurs, wait a minute. Oh, the maximum value. Sorry, I didn't read it well. There we go. Does that make better sense?
Yes, that makes sense.
Okay, and a local minimum value,
-2.
-2, that happens at +1. Okay, so that's all we're doing there. Okay, so it's not hard. It sounds fancy, but it's not hard. Okay, so we've got this graph. All right, and we need to determine odd, even, or neither. And then we need to determine the type of symmetry and a pair of points that would justify the symmetry. Well, how does that have to do with this? And this would be an odd function, okay, because it rotates around the origin. This would be an even function. And I believe that would be an even function. But let's double check.
How do you know?
Well, back there
So-
in the
Is it an even one or is like perfectly
Oh,
symmetrical?
even is symmetrical about the y-axis. Odd is symmetrical about the origin. And dang it, I thought I had it printed out. Let's double check in here.
No, even
Neither
is symmetry on the
means-
y-axis, odd is symmetry.
Yeah, I think that's what I said.
Oh, what's this?
So then would this middle one be neither because
Hang on. I'm trying to.
Oh, yeah, probably because on the y-axis. it's
Well,
not
I'm
the
wondering on that one, to be perfectly honest.
Wait.
Okay, and I don't have it in there, darn it.
same.
But it should be in the thing that I copied this morning.
B is not a function.
Okay, so,
Oh, yeah, so it's probably neither because it's not a function.
hold on. Where are y'all's papers? Really? They're not here?
I'm cold.
All right, I'll find it here in just a moment.
It's definitely even, neither.
No, the other side.
Okay,
Oh, that's on it. From
thought I had it. Okay, so even, this one's odd. Okay,
Austin, I'm sick
a
of
pair of
talking.
points that would justify the symmetry. Okay, so like this one, if we put this in there, 4 minus x squared, go to the table. So we're on the y-axis. The y-axis is right there. So a pair of points would be like -1, 3. Y'all might want to pay attention.
Pay attention, miss. I don't know how to calculate.
and this is 1, 3.
I'll get her.
Everybody pick your feet up if Austin is saying that, because it's getting deep.
I mean, this is.
Okay, and then this one, I'm skipping that one for just a moment. This one, we have to solve it for y equals, so we've got 2y cubed equals x. So y cubed equals x over 2. So y equals the cube root
How do you
of
know
x
you
over
know
2.
Look at your past notes and Chuck will say it like 20 times.
Okay, that's what I'm
Also,
talking
you're
about.
distracting me, Austin.
That's what I'm talking about, is we're not paying attention. He'll quit talking eventually when nobody responds to him.
I can't stop. It's so
Okay.
obvious.
Now, so odd has symmetry about the origin. Evens have symmetry about the y-axis. Now, I'm wondering if this one isn't even though it's sideways, because if you flopped it about the y-axis,
That's not a function.
it would do that. No, it is not a function. That's true. That's true.
It's not a function. So how could you-
I thought
So-
it was, like already symmetrical.
Yeah.
So how letter A is.
Well, I don't know. That's what I'm going to double check that here in just a minute. I'm trying to finish this one so that I can look it up while y'all start on your homework sheet that you have. And then I'll look it up and we'll clarify it. Well, let's go back and let's put this one in. Cube root. So math cube root of x over 2, parentheses, x divided by 2, close it, get out from under it, graph it. Okay. And so if we go to the table, I don't know, let's look at like 3 and -3. And they should be opposites. Or 2 and -1. That's a nice, neat point. So we have -2 and -1. And then 1, 2, 1, 2. We have +2 and +1. Okay? So here, if you look at the points, our definition actually makes more sense now. If you put in 1, you get 3. Well, then if you put in the negative version, you get the same thing. Okay? If you put in -2, you get -1. And then this one, both the signs flip. Here, only one sign flips. And here, both signs flip in the ordered pairs. Okay? Now, so what I want y'all to do is, I've got way too many of those. Yep, look at this, and I want you to start working on that, and then we'll start going over that. But I want to find the answer to this real quick so that I can clarify that.
Well, you see all these papers down here, this was all just willy-nilly, loosey-goosey.
So where is it going to be willy-nilly, loosey-goosey? Is it going to go in the
This is my
trash?
trash stack, this is just my trash stack. There was like 3 times
That
I
is
just stuff
just
the folders.
Amia, why don't you jump in there too?
Okay.
Why are you being very insulting?
You're- Because you're trash. Yeah.
That is algebra. I don't want algebra, I want
Come on.
a little cruise
Doing
thing.
your homework.
So, I gotta go there,
It's so slow.
and I gotta go.
Is it
Yeah,
homework?
we
Yeah,
don't
we're
have
doing
paper.
I found it here.
Maybe we
I'm gonna go through the
Here's
chasm.
open. Everything. I want to open that.
I want to listen to very old music right now.
like what time?
Like,
Like old humans.
Like how old?
Browse.
like really old.
Like what
Like-
year?
Like
56
Jesus
likes-
music, like the top
Oh,
of
yeah.
Jesus movie.
Definitely.
What do you
I-
think
I
they
respect
listened to
that.
back in the day? They like
They
beat
didn't
on like
have
the
music.
pyramids. They were just like.
It was just like.
They listen to R&B.
They have
They
like
listen to
bongos.
EDM. They listen to
Well,
EDM.
the Indians had music there.
Yeah, bongos.
They're like, oh, you know.
Indians did not have bongos.
They had flutes
They didn't
mixed
have
in. Yeah, but they can
What is
beat.
a bongo?
But like in
There's
the,
like two little drums.
Y'all, focus on the paper, please.
the Egyptians had rocks that they hit that made noise. Everybody.
So I did.
Yeah, and they made
That's
certain
music.
sounds, and they had like the
No, they definitely.
prints where you could tell that they were like hitting it. I watched a video about a museum, and they were talking about that.
You just get so bored that you do that.
No, it's something I recommended on my Discord server. It is happening.
Yeah, he seems like this place.
Wait, so how do you do one that?
Yeah, how do you talk?
I just
Number
skip
3
to what I
looks like a pair of drumsticks.
I'm having trouble with number 1.
It says find the domain of range.
Uh-huh.
So find the domain of range.
Oh, and.
Yeah.
I know, so
Seriously.
I did my journals and I had this boost of confidence.
So, Miss Cooper, since you happen to be the teacher this class,
Okay,
so you want to shake it. Look on it.
This is all I'm talking about.
Me You would tell me.
Okay, just keep on going this way, and this keeps on going that way, so your domain is all real numbers.
I don't know, days and until approximately and
Your
your
range
range.
is everything less than or equal to two.
Okay.
Okay, I did that. Oh, you're right, the sideways parabola is neither.
Let's go.
The sideways
also
parabola is
different.
neither. Okay, so heck, no, I lost that. The sideways parabola one was neither. It's neither odd nor even because it's symmetric about the x-axis.
I mean, technically nobody.
Okay. So you need to, you're finding domain and range on these,
And the F of 0.
That's why you don't pick.
and the f of 0. The f of 0 is 2 there.
Oh,
I'm so messed up.
Domain is all real numbers.
Wait, wouldn't it be?
Range
as well?
Is y is less than or equal
Oh.
to positive 2.
Would that be the same as negative infinity to 2?
Yes,
Okay.
it would be.
And also, wouldn't the F of 0, would it not be negative 2 also?
Mm-mm, 'cause there's nothing right here.
That's the same.
Oh, I thought it was the X.
No, you only look at it says f of 0, so x is 0 and y is 2.
Okay.
Okay?
Were the all numbers there?
Does it matter?
All real numbers, because this keeps on going that way, and so it keeps going further and further and further to the right, and this goes further and further to the left for the range, for the domain rather, and then the range, it keeps on going down, but it stops at 2. It doesn't go past 2. Okay?
Could that be negative infinity?
Yeah, you could do negative infinity is less than x, which is less than positive infinity. You could have done that for the range. Okay? Or for the domain and for the range, negative infinity is less than y, which is less than or equal to 2. Okay? So have this ready when you come in tomorrow.
I'm gonna tell her it's my birthday, so we don't watch it.
We're gonna bully the bully.
You're gonna tell who?
We're gonna make
Oh, it's her birthday today. Is Miss Holt's birthday? Yeah.
That's who?
Really?
That's
I
not
thought she would've
So
told me.
Joseph said it was his birthday and it wasn't his birthday?
Yeah, Joseph was playing everybody. He was playing everybody. Holy. There it is.